Make LLM outputs safe and reliable in Python. By the end, you will have a compact guardrail pipeline. You will know how to clean prompts, redact PII, pick the safest reply, validate JSON shape, and combine those steps into a single vetted output. I'm Professor Pi, teaching AI engineering and LLM systems from basics to advanced in simple Python. Guardrails matter because they improve safety and reliability. They optimize for safety and adherence, so models stay useful without causing harm. The trade-off is usually latency and context budget. Tight guards reduce risk, but shorten the usable prompt. In practice, a small prompt budget of a few hundred words keeps costs and latency low while preventing data leakage. Guardrails also cut down on debugging time and costly incidents in production. Think of a guardrail as a sequence of simple checks. Each check is fast and easy to reason about. They shine when you need predictable behavior from messy user inputs. One limitation is false positives. A strict rule can block valid answers. Balance is the design choice. We will build a 5-step pipeline that cleans a prompt, redacts emails, scores candidate replies for risk, validates JSON output, and then composes a final safe result you can use in an app. This snippet normalizes a prompt and clips it to a safe word budget. It starts from a raw prompt that may have extra spaces and inconsistent case. The code collapses multiple spaces into one and lowercases the text to make downstream checks predictable. Then it slices the prompt to a maximum number of words as a simple proxy for token budget. Raising the maximum keeps more context, but increases latency and model cost. Lowering it reduces exposure to long, risky inputs and speeds up inference. The printed prompt is the cleaned, compact input that later guards can reliably consume. Now we will redact sensitive pieces from user messages. This snippet redacts emails in user text using a simple pattern guard. It shows a sample message that contains an email address and uses a compiled regular expression pattern to find typical username at domain.extension shapes. The substitution replaces any detected email with a stable token, so later steps never see raw, personally identifiable information. Making the regular expression broader will catch more unusual email formats, but can introduce false positives by matching non-email text. Narrowing the pattern reduces false matches, but can miss odd or international addresses. The printed message shows the original content with the sensitive piece masked for safety. Next, we will choose the safest reply from several model outputs. This snippet scores candidates for risk and selects the safest reply by counting matches against a list of disallowed patterns. The candidates list contains 3 possible outputs, and the bads list defines patterns like violent language and phone number formats. The code computes a risk score per candidate by counting how many disallowed patterns it triggers, then picks the candidate with the lowest risk. Adding more patterns increases strictness and lowers the chance of harmful output, but may reject useful text. Reducing patterns makes selection more permissive. The printed string is the lowest risk choice, which is what a guardrail would allow through to users. Now we will check that the model returned structured data we can trust. This snippet validates JSON shape and falls back if required fields are missing. The replies list contains JSON strings, only the first of which includes both an answer and sources. The code maps JSON loads over replies, where JSON loads parses JSON text into Python dictionaries, then keeps the first object whose keys include the required set. If nothing matches the required keys, it returns a small fallback object to keep the app stable. Requiring more keys raises output quality, but increases the chance of rejecting otherwise useful replies. The printed dictionary is the first valid schema-like result the app can consume safely. Finally, we will compose the full pipeline and produce a safe final result. This snippet assembles a small guardrail pipeline and returns a safe result by chaining the earlier steps. It first selects the lowest risk string from replies using the risk counting approach. Then it applies the redaction step with the compiled regular expression pattern to remove emails. Next, it attempts to parse the output with JSON loads and confirms the expected keys are present. If the validation fails, it replaces the output with a minimal safe object to avoid crashes. Tightening patterns or demanding extra keys will harden safety, but may make the pipeline more likely to produce fallbacks. The printed dictionary is the vetted, policy-compliant output ready for use. Recap. Guardrails are simple steps that clean inputs, redact sensitive data, rank for safety, and validate structure. Use them when you need predictable, production-ready LLM behavior and when user content is messy or sensitive. One caveat is balancing strictness. Too tight and you lose useful responses. Too loose and you risk harm. Next step, tune the prompt word limit and the regular expression breadth to balance latency, recall, and false positive rate for your corpus. If practical, example-driven AI engineering helps you ship safer systems, subscribe and watch the AI engineering videos.